Cool. Nice to have you here. So this video is gonna be a little bit different. I had a friend of mine ask me to do like a little bit of more roadmap on how to become a blockchain developer. So I figured I'd just give it a try. So this is gonna be not that much coding actually, and I also suck at presentations. So as you can see, there's no PowerPoint. It's just VS Code and some notes that I'm gonna go over. And I figured maybe it would be nice to like kind of set a stage for the roadmap. So I'm gonna do a little bit of primer, like some basic information, so that the roadmap makes sense. Uh, let's dive in, I guess. So in blockchain world, like you can often hear term Web3 developer, which basically includes all the stuff that is related to blockchain, NFTs, and tokens. Um, and then there is no good explanation of Web3 is, or like good definition, I would say. Depends who you ask. if you ask if you ask a lot of crypto folks, you get the answer that Web2 is very centralized and it's bad, um, and it's like totally different paradigm shift. But in my opinion, that's not how that really is. In my opinion, it's all kind of incremental. It's evolution, right? We're adding more stuff to the mix, and same goes for the Web3. So this is just like, well, basically the whole video is gonna be just my opinion, right? But this is how I would define the Web 1, 2, 3. Web 1 is when we like starting to have internet. There started to be static sites, so like HTML and CSS, all that goodness. And what that enabled, us as a civilization is like kind of decentralized information. So like people from everywhere could now find out information what people published. So companies or universities would publish, what sort of services they offer, maybe some pricing and contact information, so on. So you no longer had to know somebody who knows that company to kind of get into contact. Um, but you would have this freedom of gathering information online. Well, then Web 2.0 came, which is kind of connected in my head with using more JavaScript, more things happening on the browser, um, and I put down here decentralized publishing. So what I mean by that is that there's more content created by users than by those companies that put up those sites. So think of it like social networks or YouTube, right? So in this phase where we are now, right away, right now, anybody in their basement can like talk to a webcam, and then maybe somebody will like look at it. And this bad channel is a good example of that. Yeah, so it's decentralized publishing in a way that people, like regular folks, get to publish what their opinion is, like to be heard, basically, right? You go to Twitter, you can tweet stuff and so on. So it's no longer the central authorities that build the tools that get to publish stuff, but also regular folks. Cool. And then Web3 is where the finance comes in. So what I mean by that is that regular folks, again, there's no restrictions on what you get to do in the finance world. So you can invest, you can send money to people, um, and there are so no like restrictions in this world, which could be good and bad, of course. Everything can be good and bad, um, but that's what Web3 stands for in my head. Like we're gonna go a little bit down about some pros and cons, and I'm gonna talk a little bit more about this, but that will be the high level definition for me, I think. Cool. So if that out of the way, let's look at the like architecture difference a little bit. What would be different? So if we look at Web 2, which is like what we have now, you would use like something like React, Vue, or Angular to build an app, web app, right? That basically runs in browser. More and more logic is in the browser, less in the backend, right? Things look very, they move around, they like kind of adjust to users, they, we have UX, UI, we're focused on that. And then if we need to do some sort of secure stuff, we have APIs towards the backend. We would use like REST request normally with some JSON in it, right? Like to create the user or to, I don't know, create an order in e-commerce project. And then you get a response, right? And then you also read data from backend. And normally you would go front end talks to backend, and backend has some secret, connection to database where all the data is stored. And all this is centralized, like the backend and that database that runs on the servers of the company, while front end runs in your browser, right? So um, that's the danger zone, right? Because the code in front end you can never be sure of. Like people can go ahead and change what's in the code that you've written in front end. They can change what the browser says, right? If you add some validations on the field, people can just remove them. So that's why you need this backend layer where you know the code that you've written is run, and you can verify stuff. So another way of Web 2 is like using some other tools. Firebase is a good example because they basically abstract away backend for you. So it feels like you're talking to database directly. There of course is a backend, but it's just abstracted away. So there are calls to some service that you haven't written, but it's like kind of no-code solution for your backend. And then you could have some serverless functions as well. So that would be traditional Web 2. This is where we are right now. Now let's have a look at Web 3. The thing is, it's not that different actually. So we're still using React, still using the front-end stuff as we used to. A lot of stuff in a browser, even more so, you would argue. And how this communication looks like now is that front-end talks to blockchain, basically. So you don't have this backend and database. They both are kind of merged in the blockchain. If this is your architecture, we kind of reference to this as a DApp or decentralized app, meaning that the app isn't centralized. That it's not, it doesn't require a centralized server to talk to, right? It doesn't need some backend or some database to talk to. It talks directly to blockchain. This is not completely true though, because if you get into details, the front-end app needs to be provided. The JavaScript code needs to be provided from some server or somewhere. So you still have some part there, but that's not that important. Yeah, so that means that there's no central backend or database, basically. I wrote here that it's more theory than practice. Why I put it there is because blockchains has a lot of limitations of what you can do. And to get around those limitations, what you would do is you would build a backend and a database again. But in theory, and the most crucial part, the financial part, you would do directly to blockchain, of course. But maybe for some reading or some statistics and stuff like that, you would connect your app to some centralized service as well. So Covalent is a good example of one of those services. Like they kind of index blockchain and provide you some aggregated data about blockchain, like what sort of tokens does this wallet holds, right? That's not the query you can do to blockchain directly. You would have to go through all the transactions to kind of figure it out. But Covalent is an example of a company that does just that. And then they expose a traditional REST APIs that you can call and get that sort of information. All right. Oh yeah, and so then if we're talking communication towards blockchain, we're talking requests to the blockchain node. So as you might be familiar with, blockchain is composed of a bunch of nodes in the network, and then they all share the same state and they do the execution. So instead of REST call, you would do remote procedure call. I messed this up. um, Meaning that you kind of, it's a different protocol that you would call, and then you send some data in that node, and the node executes some, you know, other stuff based on it and returns you. It's very similar, but it's not the same as REST. So that's why in your browser, when you look at the network tab, I believe you will not see those calls yet. They might add them, like the browsers, in the future, but it's not there yet. Yeah, cool. Let's look at blockchain stuff. So blockchain. This is by far, this is like very short description of everything. So it's just more like to spike your curiosity and then do listen to more smarter people about stuff like that. But let's stop. This is some notes that I've written about blockchain. So in my head, blockchain serves as this data layer combined with the, you know, secure environment for executing. What I mean by that is that in your backend, you know who your user is by some authentication that we're going to get into, and you know what that user is, uh, you know, allowed to do, and you also store data. In blockchain world, the blockchain itself does all that security for you, so you don't need to verify that anymore. You of course need to have some checks in your smart contract code, but the underlying like tools are already there and are already working. And then I have a bit of cons and pros. Figure I'll start with cons because you're here, so you probably heard enough of pros to be interested. But these cons are kind of important because there are a lot of limitations that I said, uh, which you need to be aware of as a developer. So it's cumbersome to connect in a way that if we're talking traditional backend, you just need the API, you just need like the URL and then maybe some authentication mechanism, and then you can just call a fetch, right, from your JavaScript code. But in here, you need connection to like a node inside a network. And because it's peer-to-peer, this network, right, the nodes are everywhere, there's no central place to go to get the node. There are like tools like in Fura that will like rent you a node or like let you talk to their node, but it's limited, right? You don't have control over that, and this is, I guess, this point as well. Like reading rates are limited, so you are limited on how many requests you can do towards that node that you're renting, if that makes sense. This is also a very important point. It's not only data, but also the code is immutable, so it doesn't change on the blockchain. All you can do is just put some more stuff on top of it, but the old stuff remains there. And what does that mean in practice for smart contracts is that the code that you've written to run is there and it doesn't change unless you put a place for it to change. So you put some like sort of variable that you can change or something like that. So that's kind of tricky because if you find a bug in your smart contract, you basically need to redeploy a smart contract, create a new smart contract, and then you need to migrate all the data there, which is really difficult and sometimes not possible, depends on the architecture you've chosen. And you know, when was the last time you've written a code without the bugs, right? So this is really tricky. So that leads to you're trying to keep as little code on the smart contract as possible and move everything outside of it. But another implication of that is that you still need central services for this stuff that is outside of the blockchain, right? And also related to that is that there are no aggregated queries, so you cannot do questions like, you know, how many times this wallet bought something, you know, minted a token or something, because it's not SQL, right? You can't do this kind of complex queries. You do very simple stuff, and mostly stuff that you already put it in the smart contract in the first place. And remember, you cannot change it. So if you have a new business requirement in the future, you don't get to amend the smart contract to like support it. But again, there are ways around it with the central services where you would build some sort of indexing or some sort of data gathering services around that. Cool. Next point is that writing takes a long time. So in traditional Web 2 world, like say that you publish a tweet on Twitter. You click a button and it's published, right? And it takes like no time at all. You don't even think about it taking some time. But that's not the case here. We submit a transaction, it goes to one node, then it needs to propagate, then it depends on like the blockchain itself, like sort of consensus mechanism they use, and how they like redistribute the information around different nodes. But it takes seconds, minutes, all the way to like never. Because, and then also important part, it depends on the gas fees that you put in. Again, depending on the implementation, but most likely. Uh, so yeah, so that means that in your front-end code, you need to have a more focus on like sort of pop-ups and waiting states and explaining why it takes so long and stuff like that. But again, this is just traditional front-end stuff. This is nothing new. It's just that these edge cases happen more often, or like it's not edge case anymore. This is just a regular case. Yeah, and then another point is that user has to pay a gas fee for every write that they do. So for every interaction that changes state in any way whatsoever, you have to pay a gas fee. And that's, can you imagine Facebook, where you pay for every post, you pay for everything. And then one important note here as well is that the fee that you pay doesn't go to the creator of that site. It doesn't go to Twitter or Facebook. It goes to like just maintenance of this network. I mean, again, it depends on blockchain from blockchain, but normally the validator or the miner would get part of the gas fee. Gas fee gets burned. Part of that gas fee gets burned as well, meaning it decreases the overall supply. So that all sounds horrible, right? Why would anybody use this blockchain stuff? So let's open this pros section. It's much thinner here. Not because it's like less pros to use it, but just because I put the most important for me. But there are of course many other pros that you could you could put in here. But this is technical talk in a way, so I'm trying to be focused on the problems or like on the things you're gonna encounter, not on the the theory of the good stuff that you're gonna get, like the freedom and stuff like that. All of the first thing says freedom to connect. So let's jump right in. So what do I mean by that? Open source, is a really powerful tool. You get to see what people have written, right? If you have a problem, you can just go to their code, figure out what the problem is, and it's kind of nice, right? And then you also get to contribute to it, and it's very powerful. But then this blockchain stuff feels like it's taking on a whole new level. What I mean by that, we've built. Recently I was working on a project, or I still am, Motoverse, which is a crypto game that kind of invests money into interest-bearing assets. So what does that mean? Is just takes money and invests them on something like stocks, right, on your behalf, and then not on your behalf, but then from the interests from that investment, we get to pay out some rewards to the players of the crypto game. And the crazy thing here is we're using Yieldiak for this service, where they have this financial product that we're using. Crazy thing is we didn't have to talk to them. in order to implement this. We just looked at their code, and it's all open, so you can just communicate with those smart contracts across the whole chain. You just read the code, figure out the API, like the interface that you want to talk to, and you do that. If you would try to do something like that in traditional Web 2 world, that would be horrible. Like if you try to do some basic stuff like integrate a card payment on your site, that already is a hassle. It takes weeks, not to months. Just the legal part of it, like you need to go through some sort of verification process, and then they maybe give you API keys to use their service. There are no API keys here. You just look at the interface, figure out how to use it, and just start using it, which is very powerful. Like you get to use it wrong, of course, but this is like the biggest pro in my head for this. It cuts all the middleman. You just go directly to the code, and then you interact with it. And you can see what sort of fees they have there and how that works. It's all very transparent. Cool. Next pros is that user owns stuff. So this is kind of related, but it's more on the user side. So the actual client interacting with your software or whatever your tool is, they have the private keys, so they own whatever assets you have, like your NFTs, your tokens, and it has implications in the way that because they own that, makes it simpler on you, that you don't need to build a lot of stuff around security about an ownership, because it's all on the user in a way, from a technical perspective. With great power comes great responsibility. Now we're shifting the power more towards the user, so we're moving the responsibility away from the creators a little bit, in a way. Cool. And then last pros, again, this is very technical point, but transactions are atomic, meaning everything you do on a blockchain either happens all or is rollback. So it's like transactions. Like there are some exceptions. You can do bad code that like avoids this, but in general, that's how it works. This is very powerful because sometimes it's quite hard to figure out a way to do transactions correctly, and especially if you're talking like parallel execution. Like you have a API, and then people can shoot their requests, and then sometimes that can happen at the same time, and in the middle of execution they get like switched, and then the other ones runs, right? That's something you don't need to worry about at all in blockchain, because things are atomic and they happen sequentially all the time. So you don't need to check state in the middle or like use some sort of synchronization tool. It's all taken care of. So it's way simpler in this sense. Cool. I put authentication as extra because this is kind of important point in my head. So again, authentication way simpler than traditional Web 2. There's like trillion types of authentication. No, not really, but if you tried ever to implement something like OAuth2 or SAML or even basic username and password, there's a little bit of hassle to do that, because if you're doing username and password, let's say that's the easiest way, you still need to kind of figure out way to store this password. You don't want to do it in plain text, so you want to hash that. You want to use some salt maybe so that it's different, like to protect against the rainbow table attacks. And all that takes focus, engineering time, and it's kind of difficult. And if you go to more like complex flows, like the OAuth flows and so on, it's sometimes tricky to get right? In Web3 or blockchain, that's all on the user. So they have their own private key, and it's up to them to keep that secret. You know their address, which is their public key, so you can always verify who the user is, like if they have access to that private key or not, because they sign the transactions when they ask you to do anything, so you can use the public key to verify. So there's basically just one type of authentication that you do, this kind of public-private key verification process. So that's kind of really cool, because it makes it very simple on you as a developer. Of course, you get to combine stuff again, because I talked about it's being more like theory to go directly blockchain. So you might need something like traditional authentication as well, maybe using, you want to log in using Google or something. But the core Web3 authentication is kind of simpler. And again, it all speaks back to this, I don't know, notion of moving this responsibility on the user themselves. Cool. I don't know if that made sense at all, but now let's have a look at the roadmap. Again, this is very subjective, so this is just like my idea about steps I would take in this order, probably, if I would be learning about blockchain again. So step 1, learn about blockchain. So these are some questions or notes that I think are important to understand. Under the hood, blockchain is secure in a way how it works. It's good if you understand why it's secure, but it's not necessary to write the code, right? It's like any other tool you're using. So it's good to check the consensus mechanism. Proof of work, proof of stake are the main ones. There are some other ones, but those are important ones. Also, what are the most popular blockchains out there, and which of them are programmable easily? So to that, I would say, obviously Bitcoin, Ethereum are up there. Bitcoin has a B script, I think, a Bitcoin script, like a programming language that you can use. It's way less powerful than what you can do on Ethereum. That's why Ethereum is preferred by developers in that way. In general, we call them EVM languages, or Ethereum Virtual Machine Compatible languages. So those are the languages that follow the same architecture as Ethereum in the way that how they execute code. And that's the majority of them. So that's why I'm suggesting next point, learn Solidity, because that's the programming language you would use on these kind of languages. And that would be Ethereum, Polygon, or Avalanche, and some others. There's also Solana, for instance, which is not using that. They're using Rust, which is general purpose language. But that's, yeah, in my head, it's like JavaScript. Again, like JavaScript, in this case Solidity, it's not the best tool for the job, maybe, but it's the easiest one, and it got the widest adoption, so it's probably gonna win, if you ask me. Yeah. And then check what layer 1 and layer 2 is, like those blockchains, so that you understand the difference. Cool, then learn Solidity, as I mentioned why. That's the most widely used programming language. Yeah, I just written what I said. Nice. Crypto Zombies is really good tool to learn about Solidity. They have a really good tutorial. They take it step by step. It's interactive and they explain stuff. This is what I've done when I started learning Solidity. This is really nice tool, and I highly recommend it. And it's for free. It's like open source. You can check it out. After you've done that, you've learned all the stuff, you now know all the stuff, you can go to practical parts, I think. Like, they are not just pure theory, right? Especially the Crypto Zombies, they actually make you write code, so that's good in my head. But then it's time for you to create and deploy your own smart contract that does something fun. So there are tools like Truffle and Hardhat that are designed to make writing code easy for you, writing smart contract easy, and have some tooling around how to deploy, how to test it, So check those out. Highly recommend. Um, so as an example, what you can do, just do a simple ERC20 token. Hidden question here is that you need to figure out what the ERC20 token is, but it's basically a cryptocurrency. So you're gonna create your own cryptocurrency, which is surprisingly easy. And as for many of these things, I've done videos on them. I might link them. But if you just search, this channel, but there are some better videos in other channels too. It's not that complicated, really. Trust me. And then what I think is really powerful is if you manage to deploy your creation out there to some of the test network. So what are test networks? On these Ethereum and Avalanche networks, you need to pay to do stuff, including deploy contract and interacting with it. As we talked, you use this gas fee to, do stuff. But they all have their test chains. In these test chains, there are specific sites you can go and say, please give me a little bit of, your native token. Like this Ethereum on Rinkaby, which is Ethereum test network example. There are more. And Fuji is a Avalanche test network. You get to request this native token, AVAX or ETH, and then you get to use it in your test. And then it works exactly as on the mainnet. So that's really good. So they have their own Etherscan variant where you get to see all the transactions, you get to see all the contracts, and you get to see all the stuff. So that's next step. Use console to interact with contract. So that's something I've used in Truffle many times. It's you do Truffle console, and then you connect to specific network, and then you from a console can interact with your smart contract. So you can call methods, you can mint tokens, and so on. And it's kind of easy to just play around instead of just building, as opposed to like building the proper web app first. Just to try it out. There's no, no HTML, nothing. You just do console. So that's nice to try. So all of the above this was basically if you're going full stack or full stack blockchain developer, which is what I would highly recommend. Because even if you want to focus on front end only, it's really, really good to know how things work behind you, because you need to interact with those things. So I'm not saying you need to become expert on this, but it's really nice if you understand the basics, I would say. So now let's go to more front end stuff. So next step, I would say, create a web app that reads contract. So you don't deal with wallets at this point. You can use tool like Infura, which gives you this access to a node that we talked about before, and then you can. Ideally, you would use the contract that you deployed here in the previous step, and then just connect to that contract and read data from it. Right. So if you've done ERC20 tokens, there's a total supply method that you can call on it, and it gives you answer of how many tokens there are in existence. So that would be very nice first step, I think, to understand how front end can communicate with backend. Basically, there's a few libraries that you would use, like JavaScript libraries. There's a Web3.js and Ethers.js, which are the more popular ones. So check them out. Maybe try both. Figure out which one works for you. Yeah, that would be really good. And then finally, build on top of it and build a write function. So then you need to do more stuff. You need to connect the wallet. You need to handle all the edge cases. That user doesn't have a MetaMask plugin in their browser, so how do they interact? So you need to show them some message, like here's how you add a plugin to your site, to your browser. And then finally you submit a write transaction. So you mint the ERC20 token, or you, transfer ERC token to some other address. Yeah. And that's all the tools you need. now you just, now you're done. I'm just kidding, of course. Like, this is a never-ending battle. You will still need to keep learning. Um, at this stage, I would say there's around 6 developers in the space. Not really, but there isn't that many. Like, it's still quite early. It's a good time to like learn this stuff. Uh, yeah, and enjoy that. It's nice for your brain, I think, to kind of stretch it a little bit. Yeah, I'll try to link stuff in the description, like around some videos that I've done that might help. But also, please let me know if this was horrible or bearable, because this is the first time I'm doing more like a talk video instead of just coding stuff. Cool. So thank you and bye.